In this video, I want to talk about glycogen synthesis and degradation. And we know what glycogen is. Glycogen is a bunch of these glucose molecules linked together. Glycogen is just a bunch of these glucose molecules linked together, creating the storage form of glucose. And that's how we store glucose. If we have excess glucose, we store it in the form of glycogen by just linking them together, creating a glycogen chain. So, for example, let's say we've just eaten a meal. So therefore we have a lot of glucose. We have a high glucose concentration because we've just eaten a meal. We know there's energy in those glucose molecules, so maybe we want to store some of that glucose. If we have excess glucose, maybe we want to store some of it in the form of glycogen. So how do we do that? If we have excess glucose molecules and we want to store them in the form of glycogen, how do we do that? Well, first, let's remind ourselves of glycolysis. We know what glycolysis is. Glycolysis is a set of 10 reactions where we take glucose and we go through these 10 reactions, eventually forming pyruvate. And we know we go through glycolysis to create ATP. But something important to realize is these intermediates of glycolysis can be used to enter their own pathways. For example, this 3-phosphoglycerate can be used to enter its own pathways to create certain amino acids. In this dihydroxyacetone phosphate, this particular intermediate of glycolysis can also be used to enter its own pathways to create glycerol and other compounds. So now that we know that, how do we create glycogen? Let's say we have excess glucose and we want to store it in the form of glycogen. How do we do that? Well, the first step of taking this glucose molecule and storing it in the form of glycogen is just going through the first step of glycolysis. And we know the first step of glycolysis is when we take this glucose and we phosphorylate this carbon-6. This hydroxyl on this carbon-6, we phosphorylate, creating this glucose 6-phosphate. And that's the first step of glycolysis. However, now that we have this glucose 6-phosphate, it can either enter glycolysis or it can be used to store the glucose in the form of glycogen. So let's say instead of going through glycolysis, let's say we want to store this glucose in the form of glycogen. How do we do that? Well, the next step is once we form this glucose 6-phosphate, is we essentially go through an isomerization reaction where we transfer that phosphate onto this carbon 1, creating this glucose 1-phosphate. So now we were dedicated going to glycogen synthesis. This glucose, once it gets to glucose 6-phosphate, it can either go through glycolysis or go through glycogen synthesis. And once we've gone through this step, now we're dedicated and determined to go through glycogen synthesis. So we went from this glucose 6-phosphate to now having glucose 1-phosphate. So now once we have this glucose 1-phosphate, the next step is we react this glucose 1-phosphate with this high energy UTP compound. So essentially the way we do this is one of these oxygens on this phosphate essentially acts as a nucleophile. We know it has these lone pairs of electrons, and one of those lone pairs of electrons essentially attack this phosphate. And we know all these phosphates are strong electrophiles. We know they're bonded to these very electronegative oxygen atoms, which pull a lot of electron density away, creating an electron deficiency and creating a very strong electrophile. So we know these phosphates are strong electrophiles. So essentially this oxygen acts as a nucleophile, attacking one of these phosphate electrophiles. And when we do that, we essentially form a bond, and when we form that bond, we break a bond. We break one of these bonds. So essentially we form a bond, and then we break a bond. And it's a little more complex. Really what happens is one of these lone pairs attack the phosphate. When they do that, they push these pi electrons up onto the oxygen, creating a trigonal bipyramidal intermediate. Then that intermediate collapses, and when it collapses, then this bond breaks and those electrons fall into oxygen. But don't worry about it too much. Essentially what happens is we form a bond, and then we break a bond, and these electrons fall on this oxygen. And when we do that, we're left with this compound, where again, this phosphate formed a bond and it essentially bonded with this entire thing, creating this compound. So now we've created this compound. And again, we've done this, and now we've essentially hydrolyzed one of these bonds. So we use some of the energy in this UTP. So now we have this compound. So why do we go through that? Why do we use some of these bonds, these high energy bonds, and waste some of these bonds to create this compound? Because now once we create this compound, notice we have a very strong leaving group. Notice this is a very strong leaving group. So now we can go through a reaction where essentially one of these lone pairs on this oxygen essentially scooch down. And when they scooch down, they form a double bond. And when that happens, now this bond breaks. And this bond breaks, and the electrons in this bond fall on this oxygen. But notice we can do that because this is a good leaving group. We went through all this work to create this good leaving group, and now we have this good leaving group. So once we do that, we're left with this compound. We're essentially, remember, the electrons fell down, forming a double bond, so we see that double bond. And when that happens, this bond breaks, and these electrons fall in this guy, and this entire group just floats away. And now we're left with this compound. So why do we go through all that work? Remember what the big picture idea is. We had this glucose and we wanted to store this glucose in the form of glycogen. So we go through all these steps where eventually we form this compound. And why is that important? Why do we go through all these steps? Because now look, we have a very reactive carbohydrate. We have this carbon which is very electrophilic. Again, it's double bonded to this oxygen, so it pulls electron density, creating an electrophilic electron deficiency carbon. And also we have a formal charge of +1, so that's even more electron deficiency. So now we have a very reactive carbohydrate with a very electrophilic carbon. So now that we have that, remember we have this glycogen molecule, which we know this glycogen is the storage form of glucose, a bunch of these glucose molecules linked together. But now we're ready to take this glucose and turn it into a form that's ready to react with this glycogen. So we can now add this glucose molecule in this glycogen, essentially forming and extending this glycogen chain. And essentially the way we do that is one of these hydroxyls essentially act as a nucleophile, essentially attacking this electrophile. We said this is very reactive. We went through all these reactions to create a reactive glucose molecule. So now we can react, where essentially one of these lone pairs attack this carbon, forming that bond, and when they do that, they push these pi electrons up onto this oxygen, creating this compound. But now we've effectively done it. We've effectively taken this glucose molecule, and we've added it to this glycogen chain, elongating the glycogen chain. So now we have this storage form of glucose. We've effectively stored this carbohydrate, this glucose molecule, on this glycogen chain, creating the storage form of glucose, this stored form of glucose. So that's a process of glycogen synthesis. And again, this step is catalyzed by glycogen synthase, which is a really important enzyme that catalyzes this step, which we regulate depending on the needs of the cell. But now we've essentially stored that glucose in the form of this glycogen. However, in different situations, maybe now we need this glucose. Maybe we're in a fasted state where our blood glucose concentrations have dropped, or maybe we need energy. So now we need these glucose molecules. Now we need these glucose molecules to be utilized. So now how do we do this? Well, essentially the way we do this is again catalyzed by an enzyme called glycogen phosphorylase, is we take a phosphate compound, of an inorganic phosphate. And what this inorganic phosphate does is one of its electrons and one of its oxygens essentially attack this anomeric carbon. And when they do that, they form a bond, and when that bond is formed, this bond breaks, and these electrons in this bond fall in this oxygen. And when we do that, notice what we have. We've essentially formed a bond, and we've broken a bond. So when we do that, we'd effectively create this compound, this glucose 1-phosphate. When this inorganic phosphate reacts with this glycogen, breaking this bond, what we're left with is essentially this glucose 1-phosphate. So now we've created this glucose 1-phosphate. We've taken this carbohydrate and glycogen, and we've broken it and released it in the form of this glucose 1-phosphate. Now that we have this glucose 1-phosphate, it's one quick reaction to create glucose 6-phosphate. Now we have glucose 6-phosphate, and now again this glucose 6-phosphate can enter different pathways. It can either be used to enter glycolysis to create ATP, or it can go in this reverse direction, creating glucose, and now it's a way to create glucose, which maybe we can now dump into the bloodstream to restore blood glucose concentrations. So again, this is the process of glycogen synthesis and glycogen degradation. But again, the key point is this glycogen is a stored form of glucose, and we can either take this glucose and store it in the form of glycogen, or we can hydrolyze these bonds, releasing glucose for whatever purposes we need it for.